Hello, my dear young friends. Welcome back to C Level Physics YouTube channel. I think all the students writing your exams very cool without any tension. All the best once again. So today we are going to discuss some basic points based on simple harmonic motion. First of all, when do we say that given motion as simple harmonic in nature? For any motion to become simple harmonic, it has to fulfill some conditions. What are the conditions here? Let me show you. Here motion must be periodic in the sense it should repeat itself at regular intervals, both in position as well as time. Right? Next one, motion must be to and from. To and from means motion must be repeated at regular intervals. To and fro are back and forth. So these two conditions nothing but oscillatory motion. Oscillatory motion. So indirectly we are saying that motion must be oscillatory. Periodic as well as to and fro in the sense oscillatory. So first condition, motion must be oscillatory. Coming to third one, force and acceleration must always be directed towards mean position. So during the oscillation, force as well as the acceleration of the particle must be directed towards mean position irrespective of the direction of motion of the particle. Am I right? And fourth one, acceleration must be directly proportional to displacement of the particle from the mean position. Am I right? So more the displacement, more is the acceleration. Why? Because more the displacement, more is the tendency of the restoring force to bring the particle back to its initial position. That's why acceleration also directly proportional to displacement. But here negative sign is saying that acceleration directed opposite to the displacement. Am I right? So implies that A equals some constant omega square into minus x, that is A equal minus omega square into x, where omega square is constant and omega is said to be angular frequency. Okay, so these are the conditions for any motion to become simple harmonic in nature. So if any particle is under motion satisfying all these conditions, then that motion is said to be simple harmonic in nature. Okay, now coming to next one, I want to express some quantities in the equation of simple harmonic motion. What is the equation of simple harmonic motion? General equation, that is x equal to a sin omega t plus pi. Now let us see what are the terms x, a, omega, pi and t represent. Let us see one by one. Here x means position of particle at any instant t from the mean position. So during the oscillation of the particle, the position of that particle at given instant t can be expressed by letter x. And next one, a means maximum displacement from the mean position. So during the oscillation, suppose particle is oscillating like that from x equal to 0. Now from x equal to 0 to it moves rightwards and reaches ultimately x equal to plus a. Here velocity becomes 0. So because of retardation, particle decreases its speed gradually and becomes 0 somewhere here. So this is what maximum displacement from the mean position. So this side also speed of the particle gradually decreases and becomes 0 somewhere here because of retardation. So here also speed is 0, that's why this position is said to be minus a. So this is what plus a, this is what minus a. So ultimately if you take modulus here, a plus a, that is 2a is the span of the oscillation. So 2a is said to be span of oscillation. Span of oscillation. Am I right? So 2a is said to be a plus a from mean position to extreme position, a from mean position to other extreme position, minus a. If you take modulus, this also a. So a plus a becomes span of the oscillation. So that's what total length of the path. Total length of the path means from one extreme position to other extreme position. The path length is said to be span. That is usually 2a. So here what is a? A means the maximum displacement from the mean position on either side of the mean position is said to be amplitude. Is said to be amplitude. So a means maximum displacement from the mean position. Usually it is known as amplitude. And omega. Omega means what? Angular frequency. In general, it can be represented by 2 pi into f. Otherwise, f equal 1 by t, that is 2 pi by t also. So where f means frequency, 2 pi f means angular frequency, right? So within one oscillation, one complete oscillation, it acquires a phase angle 2 pi. In two oscillations, 2 into 2 pi. In three oscillations, 3 into 2 pi. In f oscillations, f into 2 pi, that is 2 pi f. So that's what angular frequency of the particle, right? So here one more important term, that is bracket term, omega t plus pi. Omega t plus pi is said to be total phase angle of the particle during oscillation, and pi is said to be initial phase. If I write t equal 0 somewhere here, the bracket term becomes 0 plus pi, that is pi. So when t equal 0, phase angle is said to be initial phase. What does it represent? Total phase or initial phase? What does it represent? In fact, it's a very, very important factor, phase or phase angle. It is something which refers to the position as well as directional motion of the particle at a given instant during the oscillation of the particle. Suppose particle is under oscillation like this. Particle is moving along straight line, simple harmonically. At a given instant, what is the position of the particle, in which direction it oscillates? That's what can be expressed by this phase angle. So we have an idea regarding phase. One can estimate position as well as directional motion of the particle. That's what the importance of phase. Now let us discuss phase angle acquired by particle during the oscillation at different positions. Suppose at t equal 0, particle is at x equal 0 at mean position. Now what is the phase angle acquired? What is the phase angle acquired by the particle? Let us discuss, right? First situation, that is point number one, at t equal 0, x equal 0 is the position. For example, at t equal 0, x equal 0 is the position of the particle. Now what is the phase angle? What is the initial phase? What is the initial phase? This is what number one. 1 implies x equal to, if t equal 0, sine of omega t plus pi becomes equal sine pi. So therefore x equal to a sine pi. This can be modified as x equal to a sine pi. Now what is x here? From data 0. 0 equal to a into sine pi. Sine pi equal to 0, comma pi equal to 0. So at t equal to 0, if x equal to 0 is the position of the particle, that is when our observation starts, if particle is at its mean position, no phase angle is acquired. So phase angle acquired is 0. And next situation, at t equal 0, if x equal to plus a by t is the position of the particle. Suppose it reaches half of the amplitude, suppose t equal to 0. Half of the amplitude is the position of the particle. Now what is the phase angle acquired here? Let us discuss. Right? Now x equal to a sine pi is the equation. If I substitute t equal to 0 in the previous condition. Now x means what? Plus a by 2 equal to a into sine pi. A cancel. 1 by 2 equals sine pi. 1 by 2 means, in terms of sine function, sine pi by 6 equal to sine pi. Sine cancel. Pi equal to pi by 6 is the phase angle acquired. Is the phase angle acquired. So we can write like this. This is what x equal to 0. This is what x equal to a by 2 at t equal to 0. At t equal to 0. Now what is the phase acquired here? Pi equal to pi by 6. Alright? This is the direction of motion of the particle. Now coming to next situation. At t equal to 0. At t equal to 0. If x equal to a is the position of the particle, plus a. Plus a in the sense, it is at right extreme position initially. So now what is the phase angle acquired? Suppose if particle moves from mean position to right extreme position, for that oscillation, for that part of oscillation, what is the phase angle acquired by the particle? Let us see. Now 1 implies x equal to a sin pi, right? X means what? A equal to a sin pi. A sin pi in the sense a both cancel. Now we left with 1 equal sin pi. A cancel. That is 1. We left with 1 here. 1 means in terms of sin pi by 2 equal to sin pi. That is sin cancel. Phase acquired by the particle when it reaches right extreme position from the main position is given by pi by 2, like this. So this is what x equal to 0. This is what x equal to plus a, right? At t equal to 0. At t equal to 0, if x equal plus a, that is right extreme position is the position of the particle, then what is the phase required for this part of oscillation? Pi equal to plus pi by 2. Plus pi by 2. That means to say that particle completes its 1/4 of oscillation from the main position, right? Now coming to fourth situation. Suppose it moves rightwards and retraces like that and reaches leftwards. Suppose if at t equal 0, x equal to minus a by 2 is the position of the particle. That is, it retraces its path and enters into left side from the main position. And x equal to minus a by 2 is the position of the particle by the time when our observation starts. Now, what is the phase angle required for that oscillation, for that part of oscillation? So, in the same way, x equal to a sin pi. X means what? Minus a by 2 equal to a into sin pi. That is a cancel. A cancel. That is minus 1 by 2. Minus 1 by 2 means here from here to there pi by 2. From here to there again pi by 2. From this is what x equal to 0. From here to there x equal to minus a by 2. Pi by 2 plus pi by 2 plus pi by 6. That is pi by 2 plus pi by 2 plus pi by 6. Okay, that is pi plus pi by 6. Pi plus pi by 6. That is 7 pi by 6 is the phase acquired by the particle for that part of oscillation. So that's what sine of 7 pi by 6. 7 pi by 6 equal to sine pi. So sine cancel. We left with pi equal to 7 pi by 6 is the phase acquired by the particle. Like this. See, x equal to 0 is the main position. From x equal to 0 to rightwards. From x equal to plus a to again crosses main position and enters left side of the oscillation. That is, it reaches somewhere here x equal to minus a by 2. Minus a by 2. So it moves like that and retraces like that and enters into left side of the main position and reaches position minus a by 2. For that part of oscillation, it acquires a phase of 7 pi by 6. 7 pi by 6. Suppose if I take direct position leftwards from main position to this position, then pi becomes minus pi by 6 also. Minus pi by 6. For this oscillation, if I take like this from main position to directly to the given position, then this becomes minus pi by 6 also. If I take like this, then 7 pi by 6. If I take like this, then it becomes minus pi by 6. Okay. Next one, if particle reaches, or if minus a is the position of the particle at t equal to 0, then what is the phase angle acquired by the particle? Let us see. Number 5, right? At t equal to 0, x equal to minus a is the position. Then what is the phase acquired for that part of oscillation? Right? X equal to minus a means negative extreme position. That is extreme position leftwards from the main position is the position of the particle when our observation starts. Like this. See, x equal to 0 to extreme position plus a, from which crosses main position once again and reaches x equal to minus a here, x equal to minus a at t equal to 0, right? At t equal to 0. If I consider like this entire motion, now what is the phase angle? Pi by 2 plus pi by 2 plus pi by 2, 3 pi by 2. So same can be written as x equal to a sine phi. X means what? Minus a. Minus a equal to a sine phi. A cancel. We left with minus 1. Minus 1 in the sense sine of minus 1. 3 pi by 2. 3 pi by 2. Sine of 3 pi by 2. Sine 270 degrees equal to minus 1. That is sine pi. Sine pi. Sine cancel. We left with pi equal to 3 pi by 2. Otherwise, minus pi by 2 also. Minus pi by 2. If I take direct oscillation leftwards, then pi becomes equal to minus pi by 2 also leftwards. If I take rightwards and again leftwards like this for this motion, pi equal to 3 pi by 2. Why? Because pi by 2 plus pi by 2 plus pi by 2. Otherwise, if I take direct oscillation from the mean position like this, it may be minus pi by 2 also. So that's how one can have an idea regarding position as well as direction of motion of the particle if you are familiar with the term phase or phase angle. So that is the importance of phase angle in case of oscillation of the particle. Am I right? Now let us see one numerical. Let us see one numerical. Before that, what is meant by time period? What is meant by frequency? When do we say that oscillation is said to be completed? When do we say that particle completes one oscillation? Let us see. Suppose this is what x equal to 0 is the position of the particle. It moves rightwards and again retraces like this and again crosses the mean position. This is what x equal to plus a, right extreme position. This is what x equal to minus a, left extreme position. Again retraces like that, reaches the main position, right? This is also x equal to 0, this is also x equal to 0, right? So if particle starts from main position like this, it moves rightwards, again retraces, crosses the main position, it moves leftwards and again retraces, reaches the main position and continues forever like this, continues like that. But when do we say that one oscillation is completed? When do we say that? See, if particle starts here, it reaches the main position here and here. Suppose this is what number 1, instant 1, this is what instant 2, this is what instant 3. 3 instants. Initially, at t equal to 0, it starts from main position at instant 1. Once again, it reaches the main position one more time here and next here. Now, see, you see the direction of motion at position 1 or x equal to 0, direction of motion is rightwards. When it reaches mean position one more time, see the direction of motion leftwards. Of course, these two refer to mean position only. Hence, position remains same here and there. But if you observe, the direction of motion opposite to each other. Here rightwards, here leftwards. So, direction of motion is mismatched in both instants, right? Here rightwards, here leftwards, even though position is same. Coming to second and third instants, see here second instant. In second instant, while crossing the main position, see the direction of motion leftwards. At third instant, it reaches the main position one more time rightwards. Here also, even though these two positions refer to main position, same position, see the direction of motion. This is leftwards, here it is rightwards. So direction of motion not coincided. So that's why between instant 1 and 2 is said to be half of the oscillation. Half of oscillation. Half of oscillation means t equal delta t, time interval between these two is said to be half of the time period. Between second and third instants also. Between second and third instants. Here also, see, even though both positions refer to the same position, that's what mean position, direction of motion opposite to each other. So here also is said to be half of oscillation. Half of oscillation. So here delta t. What is the interval between these two positions? That is delta t, again half of the time period. But coming to 1 and 3. Coming to 1 and 3. Most crucial point, that's what 1 and 3. Between 1 and 3. See, at instant 1, what is the position of the particle? Mean position. What is the direction of motion? Rightwards. At instant 3, again reaches mean position. Means position remains same for 1 and 3. Of course, direction of motion also remains same. See here direction of motion rightwards, here also rightwards. So that's what here. These two are the instants between which particle repeats its motion, both in position as well as direction of motion. See, the direction of motion remains same, position also remains. Of course, between 1 and 2, direction of motion not remains same, not coincided, but position is same. Between 2 and 3 also, position is same, direction of motion is not same. But between 1 and 3, position is same, that is x equal 0, direction of motion also same. Here rightwards, here also rightwards. Means in all respects, in the sense both in position as well as direction of motion, here particle repeats its motion. These are the successive instants. These are the successive instants between which particle repeats its motion, both in position as well as direction of motion. That's what that time interval is said to be one time period. Then between those instants, one oscillation is said to be completed. Okay. So what I am telling means here, the successive time interval, the successive instants between which particle repeats its motion both in position as well as direction of motion is said to be one time period. Within one time period, particle is said to be completes one oscillation. Okay, that is the importance of phase and oscillation, time period, etc. Now, this kind of oscillation, see here, this is what one complete oscillation. Here, from here to there, 1/4 of oscillation. Here to there, one more 1/4. Here to there, 1/4. Here to there, 1/4. So, from here to there, half of the oscillation. From here to there, half of the oscillation. From here to there, like that, complete oscillation. See, this is what complete oscillation. One oscillation. So, if it repeats number of complete oscillations in 1 second, then that number is said to be frequency. The total number of complete oscillations per second made by vibrating or oscillating particle is said to be frequency of oscillation. Right? That's what N. If it is multiplied by 2 pi, then that becomes omega. N means frequency, number of complete oscillations per second. If it is multiplied by 2 pi, then that becomes angular frequency. Why it is to be multiplied here means for one complete oscillation, it acquires phase angle of 2 pi. See, from x equal 0 to right extreme position, pi by 2. From right extreme position to mean position, one more pi by 2. From mean position to left extreme position, it acquires one more pi by 2. From left extreme position to mean position, it acquires one more pi by 2. So pi by 2 plus pi by 2 plus pi by 2 plus pi by 2. So ultimately, within a time period, t equal 0, here t equal to capital T. Between these two instants, all phases are added, you will get 2 pi. Pi by 2 plus pi by 2 plus pi by 2 plus pi by 2. So ultimately, phase equal to 2 pi corresponds to t equal to capital T. So one time period corresponds to a phase angle of 2 pi. Right? That's what I want to say. Right? Now regarding numerical, during the oscillation of particle along x-axis, suppose particle starts from mean position and reaches a position which is at distance x equal to a by 2 in time t1 as shown. In time t1 as shown here. See, on numerical, this is what x equal to 0 is the position of the particle. Right, at t equal 0, it reaches x equal to plus a by 2 in a time t1, from which it reaches plus a in a time t2, right? From here to there t1, from here to there t2, right? To cover a distance of a by 2, what is the time taken t1? To cover a distance of a by 2, that is from a by 2 to a. What is the time taken here? t2. So t1 to t2. See, this is what t1. From here to there t1. From here to there t2. Directly, what is the time taken from here to there? That is t. Now, I want to know the relation between these two. I want to know the relation between t1 and t2. t1 means time to reach this position from main position. t2 means time to reach right extreme position from a by 2. Right? Now, how to know the relation between t1 and t2? See, we know that x equal to a sin omega t. X equal a sin omega t. Right? This is what P, this is what Q, for example. Right? So, to get T1, from x equal 0 to x equal a by 2. Substitute here. What is the position of the particle? That is from here to there, a by 2. Equal to a into sin omega means 2 pi by capital T into T means T1 here. T1, right? T1. From x equal 0 to a by 2. What is time taken? T1. So a cancel, we left with 1 by 2 means in terms of sine function, that is sin pi by 6 equal to sin 2 pi by t into t1. So sin cancel, pi cancel, we left with the t1 equal to t by 12. Number 1, right? Now coming to this segment, for first segment, to reach a by 2 from x equal to 0, what is the time taken? t1 equal to 1/12 of time period. 1/12 of time period. Now, I want to know the total time t from x equal to 0 to q. So, to get t means from x equal to 0 to x equal to plus a. What is the time taken t? What is t? What is t? Now, take the same expression once again. That is x equal to a sin x equal to a sin omega t. X means what? If this is the position, we have to consider total length from mean position. So all distances are measured from mean position only. So therefore, from here to there, what is the position here? A equal to a sin omega means 2 pi by capital T into small t. Right? So a cancel. We left with 1. 1 means in terms of sin, that is sin of pi by 2. Sin pi by 2 equal to sin of 2 pi by capital T into t. What is the time from here to there? That is t. So sin cancel, pi cancel, t equal to t by 4. Naturally, this is what? 1/4 of oscillation. So usually it takes 1/4 of time period. For 1/4 of oscillation, it takes 1/4 of time period. For half of the oscillation, it takes half of the time period. Right? So t equal to I by 4. Next, now how to get t2? To get t2, how to get t2? T2 means the interval between p and q. T2 can be written as a t minus t1. Time to go from O to Q minus time to go from O to P. So t2 equal to t minus t1. That is t means what? T by 4. T by 4 minus t1 means what? T by 12. T by 12. That is LCM 12. So 3 are 12. That is 3t minus t. Okay. That is 2t by 12. That is t by 6. T by 6. Now compare t2 and t1. T1 and t2. See the difference. T by 12 here. It is a t by 6. Of course, these two segments are of same path length. See, the distance between O and P equal to the distance between P and Q. But time taken are different. Why it is like that means particle is not in uniform motion. Particle is under uniform retardation here. From mean position to rightwards, as displacement increases, retardation also increases. So therefore, even though distance between O and P and Q remains same, times are not same. So T1 is not equal to T2. T1 is not equal to T2. Moreover, T1 by T2 equal to T by 12 by T by 6. That is 6 by 12. That is 1 by 2. 1 by 2. So what makes the difference to have different times even though path lengths are same means here particle is under non-uniform acceleration or non-uniform retardation, right? Right. Now coming to one more numerical. Suppose in case of linear simple harmonic motion, amplitude of the particle is given like this. Amplitude equal to 5 centimeter. Okay. And time period is 0.2 second. Now find velocity and acceleration of particle at number 1 x equal to a, that is 5 centimeter. X equal to a, that is 5 centimeter. Number 2 x equal to 3 centimeter, and number 3 x equal to 0 means mean position. X equal to 0 means mean position. Now let us see what is the value of velocity and acceleration at these positions for the given data. Right. Now see solution. How to get velocity and acceleration in case of simple harmonic motion? Already we have one relation for velocity. V equal to omega and root over a square minus x square. Number 1. Coming to acceleration, a equal to minus omega square into x. Number 2. Now substitute the values one by one. Before that, say here we have x values and a values, but omega is not there. Omega means what? Omega equal to 2 pi by capital T. Omega equal to 2 pi by capital T. That is 2 pi by capital T means what? 0.2. 2 by 0.2. That is 10. 10 pi. 10 pi seconds. Right? 10 pi second. Now, 1 implies, question number 1, x equal to a. That is 5 centimeter. When x equal to a square minus a square, 1 becomes v equal to omega and root over x means what? A, that is 5. So a square minus a square means a square minus a square, that is 0. So at extreme position, the speed of the particle is 0. Right? Now coming to acceleration, 2 implies acceleration equal to minus omega square. What is omega? Omega means 10 pi seconds. 10 pi seconds. That is 10 pi whole square. 10 pi whole square into x. X means what? 5 centimeter. 5 into 10 power minus 2 meter. Right? So that is a equal to minus 10 square, 10 power minus 2 cancel. We left with the 5 pi square meter per second square. Right? 5 pi square meter per second square. Now coming to question number 2. What about the velocity and acceleration at the position of x equal to 3 centimeter from the main position? Now question number 2. X equal to 3 centimeter. Right? Now 1 implies, see the expression, v equal to omega and root over a square minus x square. Substitute there. V equal to omega and root over a square minus x square. Right? That is v equal to omega into root over a square minus x square. Omega means what? What is omega? 10 pi. 10 pi into a square. A means what? 5 centimeter. And converting into meters, 5 into 10 power minus 2. Right? So 5 into 10 power minus 2 whole square. Minus x square. 3 into 10 power minus 2 whole square. It is 10 pi into 5 5 is 25 minus 3 3 is 9 whole into 10 power minus 4. 10 power minus 4, here also 10 power minus 4. Kept common. Now 25 minus 9, 16 under root, that is 4. So 10 pi into 4 into 10 power minus 2, that is 0.4 pi meter per second, right? 0.4 pi meter per second. Now 2 implies this is what velocity of the particle at that position. Now number 2 implies A equal minus omega square into x. A equal minus omega square into x. That is minus omega square. Omega means what? 10 pi seconds. So 10 pi seconds whole square into x. X means what? 3 centimeter. That is 3 into 10 power minus 2 meters. Right? It is in centimeters. Should be taken into meters. That is minus 100 pi square into 3 into 10 power minus 2. So 10 power minus 2, 100 cancel. We left with minus 3 pi square meter per second square. And third question, x equal 0. Question number 3, x equal to 0. 0 means what? Mean position. Now 1 implies at x equal 0, if I substitute x equal 0, root over a square minus 0, that is root a square. So 1 implies v equal to omega root over a square minus 0 square, 0. So that is v equal to omega into a, max. At the mean position, speed is maximum, that is omega into a. That is omega means 10 pi into a means what? Amplitude 5 centimeter. That is 5 into 10 power minus 2 meter. That is 0.5 pi meter per second. 0.5 pi meter per second. Now coming to acceleration. What is acceleration? A equal to minus omega square into x. A equal to minus omega square into x. X means what? 0. 0. X equal to 0 means A equal to 0. So at mean position, there is no acceleration for the particle. Why? Because there is no restoring force acting on the particle. Why? Because particle reaches its natural mean position at that instant. So therefore, no need of acting of restoring force as well as acceleration. So that's why A equal to 0. So that's about this question. So that's how one can find velocity and acceleration at different situations when you are given amplitude as well as time period. Now coming to one more important numerical. Suppose particle is under linear simple harmonic motion along x-axis as an example. Along x. If particle starts its motion, then it covers a distance small a in time tau seconds and covers a distance 2a in next tau seconds along the same direction. Then find the amplitude as well as time period of the oscillation. See, in question given like this. See, this is what x equal to 0 for example, right? X equal to 0, x equal to 0. See, this is what x equal to 0. Here particle starts from rest in the sense we can consider the initial instant at the right extreme position for example. Why? Because at extreme position velocity of the particle is 0. Here particle starts its motion from rest in the sense we can say that the particle is at x equal to plus a at t equal to 0. Right? It covers a distance a in a time tau and covers a distance of 2a. See, this is what 2a in next tau seconds. Next to tau seconds. Of course, these two are same time intervals. Suppose this is what p, position p, this is what position q for example. From right extreme position to p, it covers a distance a in tau seconds. From p to q, it covers a distance 2a in next tau seconds. Of course, these two are same time intervals, but path lengths are different. Why? Because it is moving towards main position as an example, implies that it is under acceleration. Therefore, even though times are same, but distance covered is not same, increasing towards main position, right? Right? So that's why here part starts from rest in linear simple harmonic motion. It covers a distance a in tau seconds and a distance 2a in next tau seconds along the same direction. Here distance increases. Distance increases from a to 2a means we can take it as granted from extreme position to mean position. If distance decreases, we must consider from mean position to extreme position, right? As distance increases, we must consider from extreme position to mean position, the direction motion, like that, right? Now the question is, what is amplitude? What is time period? What is time period? See, at t equal to 0, this is the position of the particle. Now when particle is at right extreme position, what is the valid expression for SHM? We know that x equal to a cos omega, a cos omega t. T means here what? Tau. Omega t. X means when particle is at right extreme position, what is the distance of the particle from the main position? That is total amplitude A. This is what amplitude A. See, this is what amplitude A. The distance of extreme position from the main position. That is amplitude A. Now when particle is at right extreme position, what is the position here with respect to main position? That is A. When it is at right extreme position, x means what? A. Measure we have to measure the position of the particle from the main position. So x equal to a equal to a cos omega tau. T means what? Tau. Sorry. When particle reaches, what is the time to reach P means tau. Here it is t equal to 0, here it is tau. So when particle reaches P, now what is the position of the particle from the main position? That is a minus a. Sorry, a minus a. We have to consider a minus a. When particle is at, otherwise write like this. When particle is at P, when particle is at P, right? When particle is at P, this is the position of the particle. But with respect to main position, we have to consider this distance in the expression. So we know that x equal to a cos omega t. When it reaches P, so this path length should be the displacement of the particle. Even though it is moving leftwards, this must be the displacement from the main position. So what is this measurement? That is a minus a. So x means a minus a equal to a into cos omega t. Number 1. When particle is at Q, when particle is at Q means it covers a distance a plus 2a in time t plus tau, that is 2 tau. In a time interval of 2 tau, it covers a distance of a plus 2a. But when particle is at Q, what is the position of the particle from the main position? This is the position of the particle. Now what is this measurement? That is a minus of a plus 2a, that is a minus 3a. So same can be written as a equal to x equal to a cos omega t. X means what? When particle reaches Q, this is x. How to get this x? Means a minus of a plus 2a. So total amplitude minus total distance covered, that is a minus 3a equal to a cos omega into, what is the time taken to reach Q from a? That is tau plus tau, 2 tau, 2 tau. That is a minus 3a equal to a cos omega 2 tau means 2 omega tau. Now this one in the form of cos 2 theta. Cos 2 theta, that is 2 cos square theta minus 1. So in next step, we can replace like this. That is a minus 3a equal to a into cos 2 omega t means 2 cos square omega tau minus 1. 2 cos square omega tau minus 1, right? That is a minus 3a equal to a into 2 into cos square omega tau. Cos square, cos omega tau, from 1 implies cos omega tau equal to a minus a by a. See here, make it subject cos omega tau, cos omega tau. That is a minus a by a minus a by a minus a by a whole square minus 1 since from 1. That is a into 2 into a minus b whole square, a square plus b square minus 2ab by a square minus 1. That is a into 2a square plus 2a square minus 4a minus a square whole divided by a square. And taking LCM, it becomes 1 into a square. So here in LHS a minus 3. So a cancel here. That is we left with a here. A into this one, a square minus a into 3a. 3a equal to 2a square minus a square means a square plus 2 small a square minus 4a. Right, a square cancel. Here minus 4a becomes plus 4a. 4a minus 3a equal to a square. That is a equal to 2a square. Amplitude equal to a cancel. That is a equal to a. So what about amplitude? Amplitude capital A equal to 2 small a. So this is what amplitude. Now coming to time period. How to get time period? Replace omega by writing 2 pi by capital T in first expression. 1 implies, see, a minus a equal to a into cos omega. Omega means what? 2 pi by capital T into tau. Right? Now replace a. That is replace small a. Okay, small a. A minus small a means a by 2 equal to small a equal to a by 2 equal to a. Otherwise replace capital A. Why? Because capital A not given directly. So capital A means 2a minus small a equal to 2a into cos 2 pi by capital T into tau. That is 2a minus a. So a equal to 2a into cos 2 pi by T into tau. A cancel. 1 by 2 becomes cos of pi by 3 equal to cos 2 pi by T into tau. Cos cancel, pi cancel. So tau T equal to 6 tau. From which see 2 pi by capital T into tau. So therefore ultimately we have cos cancel, pi cancel. Make it subject to T equal to 3 is 6 tau. Capital T equal to 6 tau. So in terms of tau, given time interval tau, time period is equal to 6 times tau. Amplitude equal to 2 times a. Why? Because distance a is given. In terms of small a, amplitude equal to a. Okay friends, with this I conclude. Thank you for watching.